connected components in an undirected graph. So we are given all these edges and number of nodes, and our goal is to find how many of them are connected. So we can see that in this part there is one connection of all of it. In this part we have all this connection in all of it, and in here there's only one connection on all of it. So you can see it as all these nodes are in one set, and in here we can see that this node's in one set, the other one is in the other set, so there are two sets. So this is just a disjoint set problem or union find. So let's see it in action of its implementation of this data structure. So let's create our union find class, and this class will contain your parent. In my previous video I have explained this union find. It's just like a very similar to that problem, only one small thing that we need to change it. Rank. Let's create our constructor union find. We will take number of nodes, and let's define our parent new integer and +1, and our rank new. And see the previous video where I have explained union find, and so I'm just going to skip all this explanation in this problem. And n is inclusive, plus, and let's find parent will be parent new. Oh, we can say I equal to I, and rank I equals to 1. So all I'm doing is just like defining union find class. It has two methods, public integer find and union. So for find, we will be taking vertex and trying to find it. So if given vertex not equals to itself v, then we will be just recursively calling it until we find its parent v, and just return our parent v. Now another method that we have in our union find, it's union union, and then we'll do v1 with v2. Notice that in our redundant problem that we have solved previously, where we are returning boolean, but here we're returning integer, because like we want to count how many connections that we have, we are doing it, how many times we have connected. So if you take a look, so given 5 nodes, how many connections you do see in this picture? We have 1, 2, and 3. So 5 minus 3, this is 2. And what about here? So we have 5 nodes. How many connections do you see? 1, 2, 3, and 4. 5 minus 4, that is 1. So that's the goal. When we are combining them together, we are counting how many times we are doing it. So let's get our P1. So find from V1, and P2 find from V2. Okay, so if this P1 equals to P2, then just return 0. Else if, just like in previous video, with our help of our rank, we can figure out which one is parent and which one is not. So rank P2. In here, rank P1 is a parent, so parent of P2 is P1. And let's also update our rank for P1. So it is rank P2. Else So parent P1 to P2 and rank P2, just opposite of the previous one. Rank P1. So in the end, we'll just return 1 because like we made a 1 connection. And in here, what we are going to do, we are going to try connect its given vertices, these edges. And so our vertex 1 is edge 0, vertex 2 is edge 1. What are we, so when we are trying to call our union to it, so union v1 to v2, this will be giving us a number. So if there is a connection, then it's 1. If there is no connection, then there is 0. So all we need to do is just like subtract from our n. So n negative. And in the end, you can see return our n. So we need to create our object. So union find f new union find, given this number of edges. Now uf. Perfect. So this is the solution for this problem.